Hello, welcome to Aircraft Maintenance Practices Unit 13 lecture. This lecture we will talk about cable transmission. So the cable systems is used to transmit command from the cabin cockpit to the various flight control surfaces on aircraft, or is to command the landing gear for extending or retracting. So cables is used to transmit certain movements. This picture illustrates the complexity of cables running through the aircraft structures. So the cables come with different diameter, sizes, and of course, systems will come with a turnbuckle. So what is the use of turnbuckle? We will talk about it in later slides. Right, this is the Airbus 310. It's a very old aircraft where this picture illustrates the cables that run through from the cockpit zone all the way to the empennage area where there's rudder and elevator. So this picture shows the control of the rudder from the pedal, and the cable run all the way from the cockpit or the nose of the aircraft all the way to the back of it. So it's a very long distance. So there are actually two cable system, RA and RB. One is for the co-pilot, the other one is for the pilot. So you can see that exploded view here. The cable run all the way and end at a aft quadrant, where then when you pull the one of the cable RA or RB, depends on who input the command, the quadrant will actually rotate. Actually, if the quadrant rotate right, quadrant will actually rotate due to the movement of the cable when you step the pedal. So then when the quadrant rotate, the whole push-pull rod will actually move, and this will indirectly rotate this top tube, and this top tube rotate. The fitting here will move the rudder, and the rudder will deflect to port or starboard, depends on the command. So this whole picture illustrates the connection part between the pedal and the rudder. So the medium that is used to move this command will be the cable. This is a very old school design, ever since from 1960s till now. Then along the way in 1975, the first also called F-16, the fighter aircraft utilized fly by wire. That means instead of mechanical control command the flight control to move, they utilize computer signal. So the objective of this lesson is to identify and describe various different types of various cables, fittings, turnbuckles, pulleys, and cable system components, and what is a Bowden and Teleflex cables, switch and fitting to cable, and lastly we talk about inspecting, tensioning, and safetying of control cable. Why do we use cables? Cables are used as linkages in primary flight control systems, which are aileron, rudder, and elevators. They are also used as engine control or emergency extension system for landing gear. Cables are strong, light, and flexible, thus make it easy to route through aircraft. It has also a high mechanical efficiency with minimum backlash or no plate that give you a precise control. The only problem we have for cable usage will be tensioning. It requires frequent adjustment due to stretching, wear, and due to temperature changes. So at high altitude, what will be the tension of the cable? Will it increase or reduce? Okay, you think about it, huh? So cable also only transmit pulling force. All right, pulling. So you have to have two cable in the systems to allow the pull and push effect. But if you be single cable, you only able to use pulling direction. Aircraft control cables, there are various type of construction and diameter given. So this is a typical common three types of construction of cables: non-flexible cable 1/7, flexible cable 7/7, and extra flexible cable 7/19. So what does this multiplication number refer to? If you were to look using this as an example, 7/7, okay, we will have seven. This is the cross section view of the cable. So when you were to take, you were to um, view from here, okay, you view from here, you will see this. All right, you will see this. So you count 1 2 3 4 5 6 7, you have 7 strands. Okay, you have seven strands make up of one cable. And to further break it down, one strand you have 7 wire. 2 3 4 5 6 7, 7 wire here make up of one strand, so you have 7 strands. So and these 7 strands are twisted or embedded to form one cable diameter from 1/16 to 3/32 diameter. All right, so if it's 1/7, then you only have this cable run, so it's very non-flexible, so this flexible. All right, then 7/19 is actually very simple. You have 7 strands, you count 1 2 3 4 5 6 7, but this one strand itself consists of 19 wires. Okay, 19 wires. This one is 7 wires, so this 19, so it provide extra ultra flexible property. So 7/19, the range of the cable diameter will be 1/8 to 7/32. All right, so the cable system is specified in the aircraft. Sorry, cable is specified in the American systems or by the British systems. So American system utilize diameter and the number of strands and wire as shown here, while British system is by breaking strength in CWT unit and nominal diameter. So you can see that it depends on which aircraft you are manufacturer aircraft you are working on, but most of the time we encounter will be American system. So the material used for cables will be either galvanized carbon steel, corrosion resistant steel wire. All right. So it's preformed into spiral shape or helical strands. Okay, so this twisted, so that give it extra strength and better flexibility if it's a 7/7 Okay, so do take note of this. What does 7/7 refer to and 7/19 refer? Can so can you name and group them? You can use this to practice. Okay, I'll move on. Cable assembly. Okay, all cable will come to an end where you need an end fitting. So it's either switch or nickel pressed. Okay, that means you switch the end fitting onto the cable so that your cable can attach to certain connection, either turnbuckle or quadrant. So switching is one of the approved method, while nickel press is not recommended. I'll explain in subsequent slides. All right, so let's move on. Types of end fitting, switch end. So most of the time the cable can have a ball end terminal, or you can switch to the threaded end terminal with attachment of turnbuckles. So we will be able to show you more about the end fittings during the practical sessions. All right. So, but then again, swaging is actually a compressed force that deform the fitting to ensure that it clamp hard onto the cable. All right. So threaded end, fork end, or eye end terminals are used to connect cable to a turnbuckle, bell crank, or other linkage in the system. Ball end terminals is actually just a ball. It's used for attaching cables to quadrant, okay, a quadrant, and special connection where space is limited. So it depends on your end fitting usage. So these are various type of switch terminal fitting available for us. So this is the ball type. So your cable actually insert into this fitting, and you have a compressive force that switch onto the portion here and clamp it, hold the and clamp onto the cables. Same thing goes to the fork end, turnbuckle end, start end, or eye end fitting. So if you were to have the cable, okay, the cable go into here, and then you have a compressive force. Later I show you the machine, and compress switch. This called swaging, and you will, because of that, the deformation of the fitting will clamp onto the cable, and this will prevent the cable from coming out from the fitting. Of course, as similar to aircraft hoses, after you manufacture this cable fitting. So this is another exercise. Long threaded end, this short threaded end. So which is a fork end, which is the eye end. Okay, double shank eye ball end, single shank. So this is just a identification purposes. Eye end this, fork end will be this. All right. So the size of various fitting will depend on the cable diameter used. All right. So this is the swaging process. All right. These swaging machines will create a couple impact force and switch the end fitting. So there will be a, when you deform the end fitting, there will be a certain diameter to measure and make sure that swaging is that carry out proper. And of course, before that, you have to do a proof test to confirm to swaging. So it's squeeze fitting onto the cable by plastic deformation. Okay, this is what I refer to. So I mentioned, if let's say you want to switch a 1/8, the cable size diameter is 1/8, 7/19 wire strands. Before swaging, right, the fitting outside diameter is 0.25, okay, a quarter inch. But after you switch, after you've been through the swaging machine, certain numbers of impact clamping force, you will have to measure the outside diameter, and it should give you a 0.219. Okay, 0.219. So this is where you put your cable in, I mentioned. Then you have a swaging machine to create a compressive force, a couple of compressive force. Then you have a plastic deformation, and you go through a go or no go gauge. If it's less than 2.19, this thing should be able to pass through the 2.219 measurement. If you can't pass through, that means the swaging process is not enough, and maybe you can switch a few more times and do the measurement again. So this is the go, not go, go or no go gauge, or not go or no go gauge. Okay, sorry, there's no T lah. Go or no go gauge to check the tolerance. So if let's say it's another quarter, your outside diameter for before switching is 0.494, then after you switch, it should be 0.438. So yeah, another go or no go gauge to measure. Just take note that of course this is manufacturer practices. You are supposed to ensure that all cables, the cable end will go all the way into the recess. Okay, so they will actually ensure that they will do that. If not, you can look at the percentage of the clamping will be half of it. So the strength instead of 100% become 50%. So and it will be catastrophic if your cable fitting were to break away and your whole flight control surfaces will have no connection. So that is the only scarier part. Nickel press process, this is by you look at the tooling, okay, compared to swaging machine. Swaging machine utilize impact force generated by hydraulics or pneumatic power. This is by human power. So it's a copper sleeve compared to the fitting we use on swaging, where it's more on steel type. So you can see that this is not a very popular process, but then again, for the learning purposes, just make sure that when you want to do your nickel press process, make sure that you clamp first by in the middle and subsequently an external. So this is what we do. But then again, this is a human power lah. So it's not very recommended, or in fact, it's not approved on commercial aircraft. So I mentioned after you manufacture or repair the end fitting, you're supposed to do a proof test. I mentioned it before in hydraulic hoses. Same thing goes to cable. We don't really always change or install a new cable. It may be years or years, 10 or years. We change we overhaul and replace the cable. So it doesn't make sense, economical sense to purchase testing equipment and for the airline or aircraft maintenance uh, organization. So rather that case, they will prefer to purchase the cable from the manufacturer, approved manufacturer, where their main source of job is to fabricate aircraft cables and supply to the rest of the airlines or manufacturer. So it's more efficient that way. So the cable manufacturer will actually manufacture the cable and do a proof loading on the switch cable to ensure that the end fittings are secured and also to pre-stretch the cable. So what is the loading type? 60% for American, 50% for British. And when you do a proof load testing, you need to hold the cable for at least 3 minutes. All right, turnbuckles. It will be much more easier when we carry out practical to explain the usage of turnbuckle. But then again, turnbuckles are used to connect cables or rods and adjust them for length and tightness. That means minor tension adjustment. So if the cable run from the cockpit all the way to the empennage, you have at least multiple turnbuckles for you to adjust the cable tension. So if it's too tight, the system will be too stiff and the control will be heavy. If it's too slack, the tension and unresponsive control and sloppy system. So it consists of a barrel. This is a barrel, and the interesting part of that is one will be a left-hand thread, one side will be a left-hand thread, one side will be a right-hand thread. So how do we differentiate? Very simple. If you look at this picture, this is a turnbuckle barrel. This is the end fitting. So it's threaded. It's threaded. So for the barrel is a female threaded part. Okay, so you can see there is a line here on the barrel. There's no line here. So when there's a line indication, it tells you that this is the left-hand thread portion. This is the right-hand thread portion. So you make sure that you get the left-hand threaded end fitting to engage onto the left-hand threaded part of the barrel. Of course, if you want to engage using a right-hand thread part, you can't engage it. Okay, the difference between left and right-hand thread to tighten or to engage, you need to do anti-clockwise. It's opposite of right-hand thread. Okay, one thing to consider after you engage the whole systems, how many number of thread can be exposed and what is the safety lock wire size to use. All this will be taught during the practical. All right. So turnbuckles are used to adjust the tension in cables. So as mentioned earlier, there is a groove, okay, or sometimes it's a hatch line. Then it indicate that you can compare lah. There's no indication on the other side. So this will be telling you these are the left hand track. Okay, and this is the cable rigging tools to be used. These rigging tools prevent the cable from twisting when you turn the barrel. Okay, we will teach you how to use these rigging tools during the practical session. When we carry out cable tensioning, this is the chart that is provided in maintenance manual. All right, and we need to use this chart to obtain the correct tension at the point of time when we maintain or tensioning the cable. Think about it. Do you think the tensioning will be the same when you carry out in Singapore, in Iceland, or in Africa? If you think about it, okay, what causes cable tension to change is actually the temperature. That's why column here there's a temperature. So the temperature will affect the tension of the cable. So if you carry out tensioning in Singapore, our general average temperature is 30 degrees Celsius in the hangar. While if you do a tensioning process in Iceland, it can be below 0 degrees Celsius. So we will have depends on the atmospheric temperature when we carry out our tensioning. So you need a thermometer. Then followed by you must identify what is the cable type and the diameter used on this aircraft system. So we have to refer to aircraft maintenance manual. The maintenance manual will tell you this particular aircraft we are servicing, what is the diameter and what type of cable is installed. So example, okay, I think there are another slide will talk about the example. So for cable control system to operate effectively and efficiently, the cable tension must be correct. So the tension value chosen is maintained over a range of operating temperature. Okay, ambient temperature. So temperature change, cable stretch, and generally it will cause wear, okay, affecting the tension. And just make sure that there is a tolerance of 10 plus minus 10% of all cables. All right. Okay, this is an example on how to use the chart to obtain the required cable tension in your ambient temperature. So if your ambient temperature is 86 degree Fahrenheit, what is the range of rigging? Example for 432 diameter 7x19 cable. So we look at it, 86 degree F. So from there we just draw in between here somewhere and draw a vertical line. Then now 4/32 is 1/8. So yep, this is 1/8 7x19. So you can see this line. This represents the range where you want to intersect. So let's say example 316 7x19, then this is the range you want to intercept. So it depends on the type of cable you have. So in this case, the example gave us is 4/32, so we just follow accordingly. Once you intersect the correct curvature line, then you draw a horizontal line, and on the left or right, it's the same. Okay, it tells you what is the required tensioning load. So it fall in between 50 and 60. So the range of that will be 55 plus minus 5.5. How do I get 5.5 pounds? How do I get a plus minus 5.5 pounds? to observe on top, there's a sentence saying that the range of that acceptable for us to read will be plus minus 10% of the reading. So 10% of 55 or 5.5. So the if you minus away and plus, then you will get 49.5 to 60.5. So if you were to measure the cable runs anywhere from the cable runs, if the reading is within the range, then good. You have a very good aircraft systems that you don't need to read at this moment. The tension is good. So how do you know what is the reading on the cable system? We will require a tensionometer. So this will be introduced to you during the practical, a tensionometer. And do take note that a tensionometer is quite special and similar to the requirement of using a torque wrench. Anything that give you an indication will require a calibration date check. So if you must, before you use, is a good practice. Every time you have to check the expiry date of this tensionometer on the calibration date. Okay, I say again, I check the calibration date, expiry date. So tensionometer is used to check the tension on the existing cable system. All right, it's the same thing like you use weighing machine to weigh your weight. All right, how heavy you are. So we use tensiometer to check the tension on the aircraft system. So do take note that we do not use the tensiometer near the pulley or turnbuckles. So that means you engage the tensionometer far away from the pulleys or turnbuckles to give you a positive or more accurate reading. So for that, you need to know there is a riser to choose. So this chart will be given by the tensionometer manufacturer. So the number of riser will represent actually is an adapter used to clamp and create a reading load by hooking onto the cable. So if it's your example using the previous example, our diameter is 4/32, which is 1/8, then the riser you use to be number 1. So in this case, the drawing here, the chart here example, they are using 3/32, also number 1. So how do you know whether this riser is number 1, 2, or 3? Is actually is engraved onto the riser, and the risers are in different sizes, shaped. So we will show you during the practical. It's easier to understand. But in the meantime, please note that there's a riser to choose from using the chart based on the cable diameter. All right. Then of course, do take note. Let's say when you use this, we are following this example, 3/32 cable, then with this riser engaged, and this is the reading. So the reading is about 24. Is it correct? The indication on the tensionometer display a 24, right? 24. But then again, you go down to this column, you look for 24. If you have 24, good. But this is not actual cable tension in the system. Although it display on the dial is 24, but the chart will tell you that you need to convert. 24 will be the actual reading on the tension cable is 30 pounds. So depends on whether is it in the range. If it's in the range, you don't need to adjust. If let's say you fall short, you need to adjust, then you have to use the turnbuckle to tighten or loosen the cable systems. Okay, you realize that most of that, it doesn't give you a direct reading. All right, so make sure that you do not read directly. It's not 24 pound, but you need to use the chart to convert. All right. All right. So I think this is repeating. So make sure that there's a chart that goes to each individual tensionometer. So make sure that you refer to the right box. I mean, in our practical, we have put the cable tensionometer in a box, and the box provided will give you that chart. So make sure that you use the right tensionometer to the right chart. Okay. One more thing is please handle this tensionometer with care. All right. Don't drop it. We have previous cohort drop one, and the whole tensionometer was damaged, and I think it's about 3,000 USD. Yeah, so we have to purchase another new tensionometer. So please protect it, and if it's not in use, put it back inside the box. So as mentioned, we do not read directly onto the dial indicator here, but you have to do a conversion. What happens if it's 46? In this case, you have to interpolate. Okay, you have to interpolate 44. This what is this number? Can't really see. So anything 44 between this range is 46. Then I believe this is 50. Assuming if this is 50, then 44. Then you have to interpolate to find the mid range of the cable tension. Okay, you need to do a carry out interpolation. So you realize there's 1/8 inch cable, then you have to use 1/8 inch cable, and then number one riser. So the number one over here is a very good illustration. You have a number one indicate on the face of the riser. So that's how we know that that's number one riser. All right. Don't worry. If there's a practical session and you'll be able to use the tensionometer, you understand what I'm trying to tell you, and practice will make you more familiar with the steps. All right, some aircraft manufacturer, they will input a tension regulator at the end of the fitting. So this tension regulator will actually maintain the cable tension as the aircraft expand or contract due to ambient air temperature. So yeah, so if because the larger aircraft will have a longer cable run, and the tension to maintain the particular tension range will be very competitive, very challenging. So they have this regulator to act as a buffer to make sure that the tension range is within the range when it's at certain altitude. Safety turnbuckle. Lock wire is carried out on the turnbuckle after we have carry out tensioning process and the aircraft cable system is within the limits. Then we will do a wire lock to ensure that the turnbuckle should not move. Or it should not rotate and work loose due to vibration. Okay, it's either you can carry out lock wiring, in this case as shown here, or you can install clip. Okay, there's a turnbuckle clip. So what is the difference? Both works the same to prevent the barrel from rotating uncommanded. But then again, the installation part will be slightly different. Lock wiring will be a bit tedious, more time consuming, while clip will be fast and easy. So during the practical, we will let you experience both and you will see the differences. All right. So over here, the chart we have to follow is based on the aircraft cable diameter. So then we will decide what kind of wire lock method and what type of diameter to use for the wire lock, 20 thou, 40 thou, or 57 thou. That means 0.020 inch diameter of the safety wire. Then what type of material. Okay. Then how many reps? This will be based on the information given in the chart. And how many threads can be exposed. What these threads refer to is the turnbuckle. The turnbuckle itself is a female threaded barrel, and the end fitting is a male. So the male will engage into the barrel, and how many threads can be exposed, okay, will be mentioned. All right, so practical part, we will do the safetying. So either a single wrap or double wrap. That's using older aircraft version. Then I mentioned earlier, clip locking, modern aircraft, and it's faster and easier. Okay, so we will explain more on how to carry out the lock wiring during the practical session. So this is the picture of a clip before installation. So there are various sizes, depends on the turnbuckle barrel diameter. So the clip itself, let me see. Yep, this is the clip So there's a part number given for the clip every time will be available for you to order from the manufacturer. So the clip itself is just insert into the barrel and hook onto the center of the hole. So it will be easier for us to show you during the practical. And there are 4 types of safety wrapped, safety lock wiring wrapped, double wrap spiral, double wrap, single wrap, spiral, single wrap. So it is also based on a type of your cable diameter as mentioned in previous slides. All right. All right, these slides, we want to talk about the inspection hole here. So this inspection hole is used or to allow the inspector to visually ensure that the male threaded end is fully engaged pass through the inspection hole. So this tells the inspector that the thread engagement is sufficient enough to prevent the cable run to break. All right. So how do you check through this inspection hole? What is the most efficient method? Imagine if you throughout the cable run from the cockpit all the way to the empennage, you have 10 to 15 uh, turnbuckles, and they are not in a very prominent position for you to do a proper inspection. How will you ensure that you have a positive check and a positive engagement of the male threaded fitting? There are 2 methods you can employ. One is using you can get a small wire, lock wire, a small diameter lock wire with you, maybe about 5 to 10 cm long, depends. And you use the lock wire to run through the hole. You poke the lock wire into the hole. If there is a you can't poke through, there are 2 holes actually. The inspection hole is a through hole, so you cannot poke through it, and there's a so-called interference. That means you're hitting the end fitting, and it's telling you that this end fitting has a positive engagement, more than enough. All right, more than enough. But if your end fitting male threaded part only all the way engaged to here, within half of the distance traveled, then it's a no-go because you can poke through it. The other way is you have a torchlight and you inspect, you shine the torchlight, you are able to access on the top of side of it, and then you can see the light pass through, then it's a no-go. You can see the light pass through, then it's saying that the engagement is positive. So these are the tooling used for required for cable tensioning. You will use you have a chance to use that during the practical. All right. When a cable runs through the aircraft structures, there are parts where they will run through the frame or the floor beam. So when you have a certain structure that the cable run through, most of the time because of due to gravity work, the cable will tend that there may have a chance if the cable tension is too slack, and the cable will actually droop and sit onto the structure. Okay, in other words, let me use a pen. If this is the side view of the structure, okay, and that's the opening where your cable will run through. Let me get okay, this is the cable. So if the cable were to droop and sit on this structure, all right, of course, then when the cable will be moving constantly in this direction when the flight control is removed, so actually there will be a chafing effect onto the aircraft structure. So this aircraft structure in red is aluminium. The cable is, I say, galvanized steel. So which will be chafed away. obviously it's the aluminum structure, right? So, and then you have to carry out repair. Will it be expensive? Yes, because you may want to replace the whole frame or the floor beam, which is very time consuming and expensive. So to prevent such occurrence, they will have a fairlids. They will came up fairlids, gomets, or even pressure seal is to protect the structure from abrasion or chafing, rubbing against by the cable. So very simple. If such occurrence happened, and we just need to replace the fairlids, which is only maybe 100 USD or cheaper, and the amount of work just to replace will be lesser in time consuming compared to replacing the whole floor beams or the repair work carried out. Okay, so fairlead should never be used to change the direction of control cable. This is true. The most you can deflect a cable not more than 3 degrees. If you need to change the direction of the cable, you will use pulley. All right, you can't use fairlead. So they also use as supports to reduce cable vibration in long stretch of cables. Okay, fairleads, gomets are open, so-called not enclosed. They may allow air to run through it. So if you have a pressures, you need to have prevent the loss of pressurization air. You will need to have a pressure seal used. So the pressure seal itself is actually this illustrates a better picture on the fairleads, and this is the air seal type of pressure seal fairleads, where this is the bulkhead where there's a pressurized air, the cabin. This is unpressurized air. It can be the empennage. So this is the air conditioned area. You want to prevent the air conditioned air from escaping out. If you were to use this kind of attachment method, then the air conditioned air and pressure air will escape from the gap between the cable and the fairleads. All right. So this is the pulley with a guided guard pin. All right. So the pulley may act as a support, better support, or change the direction of the cable run. All right. Okay, so we have pulley used on the cable system. They are used to change cable direction and to allow the cable to move with minimal friction. And you must have a cable guard. All right, a cable guard. It can be a pin or a bracket to prevent the cable from slipping out of the pulley groove. All right, so pulley come with the bearing. Okay, so it's a various sizes. Okay, so they also have a quadrant, okay, for the ball end fitting, and a bell crank and walk beams. So this is attached to push-pull rod. Inspecting the cable is to be carefully inspected for wear, kinks, broken wires, fraying, corrosion, or discoloration. So most of the time depends. We do not remove the cable runs from the aircraft systems because to reinstall back the cable will be time consuming. So most of the time we will carry out inspection on site. And of course, how do we check for broken wire is very simple. We will same thing like the checking the metal bladed holes. We use a glove, we wear a glove and use a lint-free cloth, and run through the cable run. So we run through both directions, forward and aft, and when there is a when your crop is being so-called caught by the cable while you do through a run, there is a pull, then it's telling you that there's a broken strand of wire. Then you may want to refer to aircraft maintenance manual practices to see whether you need to replace the cable. All right, but once you want to replace the whole cable run, then you will be very tedious because a lot of sidewall panels, roof panels, even gallery, those galley needs to be removed. You have to actually remove a lot of items to access the cable. Okay, so when leaks, broken wires or corrosion cable must be replaced. This is a general statement, but refer to your maintenance manual again. Alright. Cable inspection, you can refer to Google search AC4313. So I won't run through every words. You can read through the slides. It's just a general guideline. End of the day, it will be the inspector experience to identify the defect and check with refer to the menus and call for replacement. Of course, you'll be surprised that you have to show the evidence and convince the airline customers that the cables require uh, replacement. So it's not so simple as in a point of view, when it comes to maintenance, you are the inspector. You have every right to change, but at the end of the day, you must be able to get a customer to pay you to change. So you have to talk to your customer before you carry out all this major replacement. All right. So this diagram or picture shows the kind of pulley wear pattern. So this is a normal wear. Definitely you will wear because of tensioning of cable. Then you will see a large top portion of defect or damage. Then it's a bearing seizure and your pulley is not rotating. So the cable just slides through the top or bottom, depends on the attachment. And this thing is after over usage is a cable diameter too small and over tensioning occur, and this is a cable over tension and misalignment. All right, so this will give us a telltale sign. But before that, when you have all these defects, first person to notify or first person to notice such issue will be the pilot, because they will have experienced certain different scenario when they move their control columns. So they will raise paperwork and you can do your inspection. So I mentioned earlier, cable itself can only transmit pulling force. So you may require two cable runs to allow a push-pull condition using a quadrant. All right, push-pull. So the industry have invented two uh, types of cable, Bowden and Teleflex control systems, that allow two directional movement using one cable, push-pull. All right. So Bowden cables and Teleflex cable system act like a rod. Okay, push-pull rod. The rod itself you can push and pull, transmit two forces. Cable only one, pulling. You can't push. All right. But in this case, Bowden cable and Teleflex can. So let's look at it. So this is the Bowden cable. So it can pull, but the push force will be returned by the end cable fitting. It's like something like our bicycle attachment. All right, bicycle attachment. So it's not magic or something magically designed, but it's using this philosophy, pulling and return by spring. Then Teleflex cable, uh, they it does not require a spring return, but then again, it's a special pitch of wire coil is designed to engage with gear teeth. Okay, so you need a system where the cable run through this. So it can be a straight lead unique gear system or double entry. So you only have one cable run. So it's used on engine and propeller control, trimming control, and fuel valve. So it's not used on commercial flight control surfaces. Couple of issues. One thing is the patent right. Okay, so if the manufacturer they can use the push-pull rod, cable systems using the quadrant design, which is FOC, and cheaper in terms of manufacturing the whole systems, rather than you engage Teleflex and you have to pay the company that patent right to use on their aircraft design. So there's some of the issue here. So it's a bit of financial consideration. All right. So in this case, if you were to engage Teleflex cable, you will have a cable run by a certain pitch configuration. Cable run. This is uh, and one single cable to do the push and pull. So how do you check for the damage on Teleflex and Bowden conduit? Teleflex and Bowden conduits are a closed fit around the flexible cable. So this conduit must be kept free from dents, nick, or other damages. Okay, any damage found must be reported, so it may cause jam. All right, so you can't really do carry out visual inspection because it's covered, it's protected by a covered layer. So most of the time we will carry out a so-called, what is we call a flight control check or system control check by moving it on ground to ensure that smooth and free operation. All right. So this is why some aircraft before they take off, they will do a flight control check to ensure all system in place. Another type of transmitting the push and pull force will be a push-pull rod. Okay, push-pull rod is widely used in helicopter control because one push-pull rod itself will allow the transmit of push or pull force. Okay, it consists of a short hollow aluminum alloy tube and with adjustable end fitting. So is the only limitation or so-called shortfall of push-pull rod is you only can have a short length of travel to prevent vibration and bending due to compressive load. I mean, if you have to a long, let's say 10-meter long push-pull rod, the issue is with the end. This is a 10-meter. Your end is fitted. Both ends are fixed. The 10-meter long rod, what will happen will be due to the weight of the rod itself, it will droop. Okay. And this is the reason why unit can make in a short length of maybe less than a meter or that. So that's why you don't get to see a push-pull rod system from the cockpit all the way to the empennage or to the main wing. All right. So you do take note that it's quite similar. All right, push-pull rod inspection. Make sure that you check the rod is not bowed. What do you mean by bowed? Normally a rod itself should be straight. If it's due to compressive load, prolonged compressive load, it will like a bow shape. So you have to change the push-pull rod. Then the fork end hole is not elongated. All right, the thread engagement. All right, the thread engagement, there's an inspection hole. Similar. This is a female threaded part. Female threaded part here. So make sure this mere threaded part of the rod end is engaged pass through the inspection hole. So the number of threaded part engaged pass through, and this thing will not disintegrated. Okay, so we also will check the bearing. Okay, the spring. So these are the mechanical means. Okay, mechanical cable, push-pull rod. All right, Teleflex or Bowden cable. All these are mechanical means. Once you engage it and maintain it well, it will always give 100% support to flight control command, right? But along the way, improvement of technology and design, aircraft design, this mechanical attachment or command is being replaced by computers where fly by wires. So instead of mechanical control, is now electrical signal to command the flight controls to move. So then again, mechanical control will act as a backup like 777. No matter how the authority will want the aircraft manufacturer to employ fail-safe redundancy. So in case the computer fail due to there's no electrical power on the aircraft while it's flying, then you have a mechanical mean that require no electrical source or power to move the flight control surfaces. So you still need to have a mechanical control between the cockpit control columns to the primary flight control surfaces to allow roll, yaw, and pitch when whole system fail for fly-by-wire. Okay, so that's the end for this unit. Please do your job quizzes. Thank you.